Okay, welcome back. So we want to consider now an alternative method of coding. And in this method of coding, we, instead of having 0, 1, as we typically do coding of dummy variables, we replace the 0 line with a -1. So this is -1 and +1. So the question is that, let's suppose that you had inadvertently put your data into a statistical package, had no idea that that statistical package did its coding as -1 and +1. And you were then going to go for a weekend at the beach, but you thought that you had plenty of time in the train ride back, or the air ride, or the plane ride back, plenty of time to prepare the PowerPoint slides for your talk on Monday. But then you didn't realize that it used -1 +1 coding. And when you got back, you then realized that these odds ratios don't look right. When I take e to the coefficient, they're not looking like, and in fact I know they're not the odds ratios because I have the 2x2 table, so what's going on? The question that I want to ask is, suppose you did this kind of coding, can you get the odds ratio from this kind of coding? So let's think about that. Now I want to use a technique that we're going to use very, very often in this course. And it's basically going back to basics, saying that we know that the log of the odds ratio is the logit difference. So the log of the odds ratio is the logit when x is equal to 1 minus the logit when x is equal to 0. It's the logit difference. But when x is equal to 1, du is equal to +1. When x is equal to 0, du is equal to -1. So we take the logit difference, we have, okay, what's the logit when d is equal to +1? It's beta naught plus beta 1 times 1. And what is the logit when d is equal to -1? Well, that's beta naught plus beta 1 times -1. And if we take the difference, we see the difference is 2 times beta 1. So we have then that the odds ratio is not e to the beta for this kind of coding, it's e to the 2 times beta. Well, it's important to know that because now I can prepare my table for my presentation, but all I had to do, wasn't bad, is take e to the 2 times beta. And I have the odds ratio. Also, when we use this kind of coding is called deviation from means coding, and I'm going to talk about that in a little while, but why it's called that. But this is called deviation from means coding. But when we use deviation from means coding, the confidence interval is then e to the 2 times beta plus or minus 1.96 times 2 times the standard error that's produced. So the standard error is also half as large as it should be in the computer output. Okay, and so just so you know that it can be done if you have +1 -1 coding, it's fairly simple in this simple case of a binary outcome variable to get the odds ratios, but you have to do a little bit of work, and you have to be aware of the fact that the only time e to the beta is the odds ratio is when you have 0, 1 coding for your dummy variable. Okay, so that's all we want to do for week 3. You'll have a homework assignment that you'll do, and again, as in the past, work through the homework assignment, use the solutions that we gave you, and you should be able to be well ready for the material in week 4 when you finish that. So have a good time with the homework, and see you at week 4.